Okay, we are going to start today about is physics superposition of waves, in which first of all we will have to go towards diffraction of waves. Diffraction of waves. Diffraction basic means like if there is an obstacle and waves are coming towards it, then they start bending. For example, waves are coming in this style. What will happen when they will come near it? They will start bending towards it, like they are going to start to move like this format. The bending of waves across the sharp edges of the obstacle over there is called diffraction over there. So I can say it is the spreading of wave. It is spreading of waves when it passes through a slit. When it passes through a slit or an area on edge or across an edge or across an edge over there. If we simply say here, for example, I am taking an obstacle over there and I am providing it in the form of an small slit over there. This small slit is, we can say, a obstacle in the pathway of the waves, which is having a small hole over there. What will happen that, for example, these are the parallel lines are being shown in the form of waves. When they are coming and stopped because of this obstacle and coming out in the form of circular waves over there. This spreading of waves across this small edges, then it is going to increase in this phenomenon. This is called diffraction. This bending of waves is going to show that they are going to be taken. After all, if I take the waves by only, this is the first case. In the second case, I am saying here, the obstacle is present over here and the waves are coming in this format. What will happen after passing this point? They will start showing the bending towards it, like in this format. They are showing their bending across the edges, which I said when there is a slit is having a hole over there, then the wave starts in the above. They are straight line as they are before the slit they are passing, and after the slit passing they are going to be shown in this format. So when we say slit size is being taken exactly, the difference between one wave front to second wave front is called wavelength over there. And we can say here, if we say that they are moving straight, as like there is no obstacle for the upper part, but yet for the lower part they are showing the bending towards it, and they are bending towards the obstacle over there. They are being shown in this format. And here in the first case, I say that it is maximum diffraction because both upper and lower sides are being stopped by an obstacle over there. So here we will say on which factors the diffraction is going to depend upon. Diffraction is going to depend upon amplitude of wave is going to decrease during diffraction as energy spreads over in this format over there. I will say during diffraction, the wavelength or amplitude. Diffraction, the amplitude decreases. Why I am saying this like that? Because the original amplitude is like this, but right now when it is coming out, its amplitude is very small. Even though when it is going away, then I can say in this direction it is flowing away, then its size is increasing step by step. And we say during the diffraction, the amplitude decreases over there as energy spreads. As energy spreads across the edges, across the obstacles, small hole in the form of slits over there. And this diffraction is also being taken that remember one thing more, you can say according to the wave formula, V is equal to F lambda, but all three factors, speed, frequency, and wavelength, are remaining constant over there. And we can say about it, for example, let's suppose I take here a slit which is having a red light coming towards it. I'm having a source over here, and I'm saying a ray of red light in the form of laser is coming here. After that, what is happening? After passing through a very narrow small slit on the screen, it is going and it is showing it spreading in this format and in this format to be shown on the screen. And light diffracts as it passes through a small slit, like we can say this is our source in the form of small bulb. Then light is coming out in the form of this diffraction pattern, in which the amplitude is increasing as it is moving away from it. And uh, when slit size, remember that this slit size should equal to your wavelength of the red light which is coming out from the source over there. And intensity of light also will decrease because energy is going to split up into the different format over there. Here I will talk about intensity, which I said it is going to decrease over there. Then I will say intensity is having, for example, if I say, if I'm showing the intensity graph representation over there, then I say before diffraction, let's suppose the intensity is showing this graph. After passing, it is before diffraction. According to before diffraction, I am saying here before diffraction, it is the intensity which is showing its peak at this point. But after diffraction, what will happen? That this peak is going to spread up, like I am saying here in this format. Now it is spread up. So its maximum peak intensity is going to decrease over there. After the phenomenon of diffraction, little bit explanation. Now I am moving towards the interference. Interference, basically, interference. I will say here, when two or more waves of same frequency and amplitude, of same frequency, move in same direction, they superpose with each other. They superpose with each other to give algebraic sum of their amplitudes. Let's suppose I say here that there are two waves given over here. And I am saying here that the two waves are being shown in this format. This is the wave number 1. And the wave number 2 is having the same frequency, but the amplitude is less. When I join both of these waves, what will happen? That I will get a reinforced wave over there, which will have larger amplitude now, as the algebraic sum of all the points over there. So this is
तो
called,
सर वो दोनों वेव्स की जो एम्पलीट्यूड्स हैं वो ऐड हो जाएंगे।
yes, they will be added as algebraic sum of both of these waves over there.
जी।
Wave number 1, wave number 2, and it is wave 1 plus wave 2. And this is called,
इनकी फ्रीक्वेंसी सेम थी इसलिए इनको ऐड किया था ना।
जी जी
इनकी फ्रीक्वेंसी सेम थी इसलिए इनको ऐड किया था
जी
ना।
जी 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 constructive interference is this. If I am going with the waves in such form, like Now I am having the waves with the same frequency, and they are moving in same direction also. One condition is same frequency, second condition is moving in same direction for showing the
जी
interference pattern over there. Let's suppose I am taking two waves now in this format. This is my wave number one, and now I am taking the second wave in opposite way. Then their algebraic sum is giving me no resultant over there, and my wave is staying along the horizontal line to show that there is no peak, zero displacement, zero amplitude over there. Then this is called destructive interference over there. Interference. And if I say that even though their frequencies are same and they are showing this pattern over there, then we can say here that principle of superposition is exactly same as I tried to define the interference over there. Principle of superposition states when two or more waves superpose with each other. We will just ignore the word same frequency, move in same direction like that. We will just simply say when two or more waves superpose with each other to give an algebraic sum of their amplitude. This is called principle of superposition. And this was our first concept of interference. Then there will be also the another concepts related to diffraction and stationary waves will be given. In stationary waves, we in the previous video we have studied about when two or more waves of same frequency move in opposite direction, then they superpose with each other to give the stationary waves over there. And the another phenomenon number 3 is related to beats over there. If when two or more waves of slightly different frequency move in same direction, they superpose with each other to give the algebraic sum of their amplitude is called beats phenomenon. I have already told you though two more phenomenons that was related to number one. Number two was stationary waves of principle of superposition over there, stationary waves, and number 3 was beats. In case of stationary waves, where we say when two waves move in opposite direction and get the algebraic sum over there. In beats, we say slightly different frequency of two waves going to superpose with each other to give the beats phenomenon over there to be taken into account. So always remember that if he is asking, write the conditions of interference, which we have just explained above. And
हाँ
yes, you want to say something?
नहीं नहीं सर
Okay. The waves must meet at a point. Waves must meet at a point. Means they should have same frequency. Must meet at a point at least. This is the first condition. Second condition, they must be of same nature. If we can't take like longitudinal or transverse waves, we should take of same nature. Both should be longitudinal or both should be transverse waves, same nature. After that, we can say here that for number 3, I will say they should have approximately same frequency, or we can say they should have same time period. Same frequency. These are 3 conditions. If two waves are obeying this, then we can say it is going to happen. For constructive interference, I have shown you the example how they are going to reinforce their magnitude, and for destructive, I have shown you like how they are giving the resultant in the form of zero form. But if I say here different types of waves are being taken, then their resultant can be given if we are having destructive interference in those waves. And there is also intermediate interference. that even though their frequency is same, but the waves are starting at different points, then they will also have the net value over there. After that, there is path difference. Path difference. Path difference means, for example, I say that there are two sources like S1 and S2, and the wave is coming, and this wave is traveling a distance this wave is traveling a distance this. Means I say both are traveling equal distance and the path difference is 0. Then I will say here that it is meeting at point P, let's suppose. Then path difference will be, this is distance 1, this is distance 2. If I take the path difference delta S or delta D over there, then I say it should always equal to n of lambda. Why I said so? For example, I am saying here, in this case, I said both are equal. Then there will be exactly equal to 0 or will be equal to exact the wavelength over there. But if you take, for example, S is taken here and you are making this point here and your S2 is here, and what will happen? This has traveled very less distance and it has traveled very large distance. Then this path difference of D1 and D2, delta D, will equal to n lambda, which means the number of wavelengths being multiplied with that distance to be showing the bright fringes at the point P's over there, P dash over there, to show the constructive interference. Then they're being taken in the form of n lambda as its path difference. If the source, both source make, while I'm taking that they are in phase, at, as I said, they are reinforcing for constructive interference, or they are destroying or showing destruction over there. In both cases, I will say here, it will give, destructive will give dark fringe and reinforce will give a bright fringe over there. In this case, we say when we are getting in phase for bright fringes over there and we are not getting the destruction over there, then we will say both sources makes the same features like crust and trough are going to meet with each other. Crust are going to meet and trough of transverse waves are being taken over there. But in destructive case, we say crust is falling on trough and trough is falling on crust. Then we can say it is going to be taken over there for path difference to be taken into account. If we are saying that how we our path difference is being taken in the form of n lambda, what does it mean basically? Then I can say if it is constructive, then we can say it is going to be used by the formula n lambda, where n will be starting from 0, 1, 2, 3, like that will be our wavelength. And if I say it is taken for destructive, then your n value, I want to vary it according to the value of 0.5, 1.5, 3.5, 2.5, 3.5 will be taken over there, 2.5, then 3.5. Means I can say here my n value for destructive is being shown half. 0 and 1 will have destructive between both of them, that will be 0.5. Destructive will have between 1 and 2, that will be 1.5. Between 2 and 3, that will be 2.5. That will be shown for destructive interference, can be taken into account for showing the path difference of the values being taken over there. So when we talk about when there is a constructive interference, then I said there will be a bright interference or bright fringe will be going to form. Constructive interference. Then I am telling you about interference. For constructive interference, I will say here the phase difference between waves at a point of interference is equal to always 0. Delta phi will always equal to 0. And the path difference, as I said, delta D or delta S, we can take as path difference. Then we say it is equal to n lambda, and n will be taken as 0, 1, 2, 3 for we can say the points where they are reinforcing and vibrate with the phase, then n is taken as 0, 1, 2, 3, up to so on. That will be the points. For destructive interference, the phase difference will be taken as 180 difference over there. Wait a second. When I am talking about destructive interference there, destructive interference, then our phase difference are we can say phase difference between waves at a point of interference is equal to always delta phi will always equal to 180 degree, and they are going to cancel out each other effect, or we can say also the pi radian over there in the form of path difference. And we will say here that when they are moving in phase way, then n will be taken as uh, in phase. When we say they are in phase, then I say it is 0, it is 0 0.5, 1.5, 2.5, up to so on. Here I have written for both of them as in phase in both of these cases. But if I say out of phase, going to show the constructive interference, out of phase here, then I will say the values for n will be 0 0.5. This is, I am writing for constructive interference now. Out of phase 0 0.5, 1.5, and 2.5, up to so on. On the other hand, if I am taking out of phase for destructive interference, then I will say it is 0, it is 1, it is 2, it is 3, for out of phase values to be taken in the form of n over there. So this was our interference, how to show the constructive and destructive interference. Now there is an important topic related to your point of view exams over there, that is related to Young's double slit experiment. Double slit experiment. Young's double slit experiment basically states like, I will have to take a source and then I will try to use that source. Let's suppose I'm taking a double slit. Double slit means this is a slit having one hole and another hole also, means there should be two holes present before the source is throwing its light, like dipper vibrating on the surface of water, like that. I'm saying it is happening. This is a source over there. What will happen? This source of light is going to throw its light in the form of wave fronts. When wave fronts are reaching at this point, what will happen? They are coming out in this pattern in the form of wave fronts, and it is also releasing its wave fronts in this pattern. Then what is happening when they are moving away from their these slits over there? There is also a screen available, and on this screen they show a pattern of maxima, minima. I'm saying here dark and bright, bright, then dark, then again bright. This is dark, then bright, then dark, then bright, and then dark, then bright. This is the whole pattern is going to be shown on the screen in the form of fringes over there. Then bright, dark, bright, dark, bright, dark, bright, dark, bright, dark fringes, bright, and dark fringes, bright and dark fringes are being to shown as a complete small fringes to be seen over on the screen over there. And when I say, then when bright will be formed over there, then I say crust, crust, or trough are meeting with each other. When I am saying there is a dark fringe, then I say it is crust trough, or trough crust are meeting at those points over there. And the pattern of bright is named as maxima, and for dark fringe it is named as minima over there. And for this experiment, we simply say here, we will have a pattern of the values that the central value, which is coming from the center of the slit over there, I'm saying like this, then I say that this is being taken as n is equal to 0, like it is the zero order maxima. Zero order maxima at the center. Then above is going n equal to 1, n equal to 2, n equal to 3 for upper. And same we can say for the lower one, I will say it can be n equal to 1, n equal to 2, n equal to 3. So these are the maxima to be shown over there in the form of zero order maxima, first order maxima, second order maxima, third order maxima, and both will be taken upper and lower. For example, you are calculating third order maxima over there, then upper third order and lower third order both will be same over there according to their magnitudes over there. So here we say that bright fringe is maxima and constructive interference, and that for that purpose we will say here that if there is constructive interference, then we say path difference is n lambda, and n will be it for 0, 1, 2, 3, 4, and for minima path difference is equal to n lambda again, but n will be taken as 0.5, 1.5, 2.5, like that will be taken for Young's double slit experiment over there. And here I want to show some letters like alphabets, which we will use or manipulate for the calculation of numericals over there, that the difference between two small slits will be named as alphabet letter A, which will be called slit separation. Slit separation. After that, we say there is a distance between the screen and the slit, which is called distance between the slit and screen over there will be shown with the letter like capital letter D over there. After that, I am saying the distance between fringe separation over there, like from zero order to first order, like that. This distance will be highlighted as X over there, which we say that it is fringe spacing. And if I relate both all of these variables in a complete mathematical form notation, then I will say here that lambda x is equal to lambda d over a. From here, I can say that fringe spacing is directly proportional to wavelength. Means if you increase your wavelength, fringe spacing will increase. If you increase the distance between your screen and slits, fringe spacing will increase. And if you increase the slits separation over there, then fringe spacing will decrease over there. So remember that your fringe pattern is going to depend upon wavelength, and it is going to depend upon distance between the screen and slits over there. It is going to be depend upon the fringe slit separation A over there. These are three are responsible for mainly according to this formula, your fringe pattern. And if I take some other factors which are going to play the role, how they are going to be taken into account, that I say the fringe pattern can be disturbed, that will be related to intensity of light. These three are the main factors, 2 and 3 according to formula. But the fourth one is related to, we can say, intensity of light. Intensity of light, on which the brightness or darkness of fringes is going to show the different pattern over there. And we can say intensity of light coming from both holes over there, coming from both holes. Fringe pattern also depends upon them. And intensity of coming from one of the slits is reduced and other one is going to increase by using some filter over there, then it is also showing the difference of pattern over there. So basically, I will say these are the four factors which are going to play the role for different patterns of fringe pattern over there, differentiating into each other over there. After that, I will say here there is a next section that is called diffraction grating. What is basically diffraction grating over there? Diffraction grating is basically, I will say that when light diffracts, then from the main source to the whole screen over there, let's suppose I try to make a conceptual picture over here. Let's suppose like that there is a diffraction grating plate over there, and on its surface you are falling a laser light over there. Laser light over there, it is falling on this surface, and what will happen then? I say there is a screen, and what will happen, it will show that it is going to the central point straight, showing your value of n equal to 0 at that point, like theta is 0 and n is 0, and it is the central point over there. Then what will happen, your first order will be taken as in the form of this will be named as your n equal to 1. That can also be taken in the form of n equal to 2 over there, sorry, 1 over there. So this whole sequence of going up and down will be shown in the form of our bright, dark fringes. When I told you about Young's double slit experiment, then I was telling here that it is 0 order, first order, second order, third order. The same pattern is going to be shown for diffraction grating over there. As I am saying here, that it is n equal to 2 over there. 0 order, first order, second order, and third order can also be taken over there. So n equal to 2 will be taken. So remember that the angle between the two will be taken as the sum. Like for example, I'm saying the first angle is showing for first order or second order. I'm saying that it is the angle 20 degree on the upper side, 20 degree will be also on the lower side. If it is 10 degree, then it is also 10 degree to be taken with the 0 order pattern over there. And here I will say, as the light diffracts and interferes, forming an interference pattern in the form of dark and bright fringes over there, then central fringe will always bright. Remember that when n is equal to 0, central fringe is bright. Then we can say brightness of spot decreases sideways over there. Brightness will going to decrease over along the sideways. What I should say about it, I will say that brightness of spot will decrease across the edges or across the sideways. Across sideways over there. And I can also add one more point over here, that gap between slits increases over there, or we can say pattern is most symmetric over there. So for both of these cases, then I will say for relating this diffraction grating, we have a formula that d sine of theta is equal to n lambda over there, where I can say n is order of maxima, like 0 order, first order, second order of maxima, and lambda is wavelength. Lambda is wavelength over there, where on the other end, the theta is the angle, between, theta is angle between 0 and where n is equal to 0 order and nth order of maxima. That can be 1, 2, 3. Nth order of maxima. And the D is basically slit separation length of one line. D is slit separation, or we can say length of one line. Of one line to be drawn or calibrated over there will be being taken into account for this phenomenon over there. In the next section, we will start about diffraction of white light and how it is going to show its phenomenon. Then we will always have to follow for diffraction of white light. I will say that we have basically total 7 colors comprising it. Web wire. This is the pattern. R is for red, Y is for yellow, O is for orange, G for green, B for blue, indigo, and violet. So these are the color patterns. And when we say that our first order spectrum and second order spectrum to be shown over there, then this whole pattern is being taken. For example, I am saying that this is the point on which the white light is coming and falling down. Central point will remain as white light. And after that, I will have to start violet above, violet down, indigo up, indigo down. So this whole pattern will be going on, and at the end I will have a red at up, and in the same way I'm saying downside, a red down. So this will be our light pattern to be shown according to the formula d sine theta is equal to n lambda over there. So in this way, I can say when white light diffraction is taken into account, then we can say for longer wavelength, will have more angle over there. If I increase this wavelength, this angle will be longer over there. And we can say when white light have n is equal to 0, like as I shown as white light when n is equal to 0 over there as 0 order, then I will say at wavelength colors perform like constructive interference and they combine to form white light over there. Means it is a bright fringe on the according to diffraction point of view. And on the all the others, we will say they are having the longer wavelength is increasing because violet is having the minimum wavelength over there. And in this pattern, our whole sequence of up and down will be taken into account for diffraction of white light over there. This is your today class related to diffraction grating and Young's double slit experiment over there. You try
Ji,
to
sir.
use the formulas and basic concept of constructive interference and destructive interference and
So the
diffraction.
class is about to end, like we just have 15 seconds left.
Yes, what are you saying?
The class is about to end, sir. We just have 10 to 15 seconds left right now.
In the next video, let's check what you are asking over there. Because now, right now,